Hi guys, welcome to today's lesson. So today we are going to look at a very interesting concept, guys. I promise you, if you follow everything that we're going to talk about, this is going to set the tone for your mathematics career until you finish your mathematics career, whether at higher learning or just at school level. But I promise you, it will be the best thing. And this is simultaneous equations. Let's firstly have a look at what is this all about, and then we can then look at some questions that we are going to do together on this particular show. So let's have a look at it. Now, firstly, remember we always look at the question, right? So how can you then find a solution to an equation if there are two or more variables, right? If there are three or more variables, if there are five or more variables, how do you then find a solution to that? That's the main thing that drives using a simultaneous equation. By the way, if you Google simultaneous, it will always just tell you it's doing something at the same time. So you know the types of equations, we've been talking about these, but mainly now we're going to look at solving simultaneous equations, and there is two methods to do that, which is called the substitution and the elimination method. We'll also break them down into pieces at a later stage. Firstly, we need to look at what does the word simultaneous mean, as I just said now, and multiple variables. That's the key words for us today. Now, a linear equation with the two variables, right? So consider an equation that has two variables, which is 3x minus 2y equal to 8. We've been looking at a single variable most of the time. Now, the question here will be how many values of x and y will give you the correct solution. So how many values of this x here and that y there will give me a constant of 8? That's the question here. How do I then find that, right? Firstly, we're going to use a table to do this, and then at a later stage, I will show you how to do this algebraically. So firstly, we look at if my x value is minus 2, what must be my y value in order for me to get an 8, right? So this actually means it's 3 into negative 2 minus 2y equals to 8, right? And minus 2 by the 3 will give me negative 6 minus 2y equals to 8, and this will be minus 2y equals to 14, then y will be equals to negative 7, right? So it means this goes with negative 7. If x is 0, then this will give me negative 4. If x is 12, it's 3 times 12, which is 36, and then my 8 minus 36 will be 28, and 36 minus 8 will therefore be 28, which if I divide it will then give me 14, a positive 14, right? And then you can take any other value again. Maybe let's choose y now. Let's choose y to be 5. And I want to know what must be my x in order to do this. So it means it will be minus 2 into 5 equals to 8. And minus 2 into 5 is going to give us negative 10, plus the 8 will be 18 divided by the 3 will give me 6, a positive 1, right? So you can already see what this is trying to tell us is there is going to be an infinite number of solutions to this particular question. But now, how do we then narrow it down such that we only have one solution? That's the question here. But let's have a look at exactly what this is. Now, the answer here, as I said, how many values of x and y will give you the correct solution? There is an infinite pairs of x and y. Now, what do I mean when I say infinite pairs? We call these the ordered pairs, right? It's normally an x value and a y value, and we order them using brackets. Now, to represent ordered pairs, we use a Cartesian plane, right? So the ordered pairs of a linear equation with two variables can be plotted on a Cartesian plane, which I'm also going to show you just now. And these ordered pairs form what you call a straight line. So if I have one pair there and another pair there, and I join them, they normally give me a straight line like that, right? But let's look at a typical example. So with the example that we've been talking about, 3x minus 2y equal to 8. To plot this, it will give me a straight line like this, right? One pair will be at this point, and another pair will be there, and there will be a lot of pairs on this line going up there. Remember, at any point on this particular line is an ordered pair, which comprises of an x and a y value. Now, when we link it to the simultaneous equations, right? When asked to then solve a simultaneous equation, we need two linear equations, because now we're only going to focus on the linear equations and not the quadratic equations. But these two linear equations must have two variables that are taken. And why is this important? Both the equations will have a set of an infinite number of ordered pairs, but one solution, right? The solution of a system of two simultaneous linear equations will then be a unique ordered pair which satisfies both the equations if you solve them simultaneously. If we quickly go back to what I've done with the table, all right, you can see this I did not solve simultaneously. I substituted my minus 2, I substituted my 0, my 12, and then my 5. That was not a simultaneous thing. Hence, I got a number of solutions for the value of x and y. So this will be x and that will be y, so it will be an ordered pair. This will be x, that will be y, and that will be an ordered pair. But if it's two equations, there is only going to be one unique pair which will satisfy that equation at all times. Now, consider the two equations that I have here, right? So I need to plot this. Already, I've shown you how to plot that one. Now I need to plot this 4x plus 2y equal to 6 and try to see what it looks like, right? So let me just show you quickly what we normally do, because I know you've done plotting before, but let's quickly look at it. So firstly, I will let my x to be 0, which will be 4 and 0 there, plus 2y equals to 6. So this will be 2y equals 6. Then my y will be equal to 3. So it means one point that I'm going to plot on the graph is 0 and 3. And then another point will be y being 0, so that becomes 4x plus 2 into 0 equals 6. This becomes 4x equals 6, and then my x becomes 3 over 2. So it means that's 3 over 2 and 0. So these are the 2 points that I'm going to plot in order to join them to form a straight line. So this will then look something like this, right? So this is the first one that we looked at together. I plotted this when we started. Now the new one will then now be this one that I have here. But now, why is it that we only have one solution? We first now need to zoom in at this point where they are intersecting each other, because that's where the beauty of what we are going to do will then come in. So you will see that the point of intersection, which is actually where the two graphs pass each other, is at the point 2 there for x and minus 1 there for y. So you can already see that it means that my unique point will then be this one that I have here. This will be the unique point that satisfies these two equations that I've been talking about. So the point of intersection, as I said, is 2 and minus 1. You can see on that graph there by the corner. And then the value of x equals to 2 and y equals to minus 1 are then said to satisfy the equations simultaneously. So if I substitute both of them at the same time, I will get the correct answer that's on the right-hand side. But our big question now is, how do you then do this using algebra, right? That's our really big question here. And just on my mind map here, remember I said it's going to be these two methods. But for now, I want you to just think about everything that we've done thus far. So remember, excuse me, the point of intersection of these two is one unique point. So they will not intersect here and there and there. That will never make sense. They only intersect at one point, which is the one that satisfies those two equations that we have. But now, as we go into the ad break, I want you to think carefully about how do I then find this using algebra? So algebraically, how do I do this? I showed you using graphs. I drew the two graphs, which we are familiar with at the moment. But now how do we use algebra to do this? Just think about that. And after the ad break, I will take you through it with some examples so that you can see everything that we need to do. Stay tuned. All right, guys. Hi, welcome back from the ad break. So we've been looking at a whole lot of things, right? But for now, the main thing that we actually looked at is drawing two graphs that satisfy two equations, right? Two linear equations. And we said there's only going to be one point that satisfies those two equations. But remember our big question, which I'm just going to show you now. So our big question is, how can we then determine the point of intersection of two linear equations algebraically? And that we are going to do with method 1, and that's the elimination method, and method 2, which is the substitution method, which we're going to do at a later stage. So the elimination method, this is the method for solving a pair of simultaneous equations that reduces one equation to one that has only one variable. Because remember, if I give you 2x plus 5 equals to 3, this you can definitely do. But if I then make it plus 5y, it then becomes a different story, because now it means you must know one variable. So elimination is such that we either get rid of the variable of x, we solve the y, and then substitute later, or we get rid of the y, solve the x, and then work it out later. The steps to do this, the very first step will be, whenever necessary, you need to first rearrange both equations so that the x terms are first, followed by the y terms, and the equal sign, then our constant. Please try to do it in this order most of the time, right? So it must be maybe ax, a is a constant value, plus by, which is a constant value, is equals to c, which is another constant value there, right? As you saw with the previous examples, maybe 2x plus 5y equals to 8, like this. So you always start with the x, follow with the y, the equal sign, and then my constant on the other side of the equal sign. If an equation appears to have no constant term, then you know it means that my constant term is always going to be 0. The second step is you need to multiply one or both the equations by a constant that will allow you to then either subtract or cancel either the x or the y value, so that you are left with only one variable. But how do you cancel that? You use addition or subtraction. So it's always maybe the first equation minus the second one, or the second one minus the first one, or adding both of them so that one variable cancels, right? And then the third step will be you add or subtract the equations. Why do you do that? You want to only remain with one variable, right? You want to remain with one variable so that it is easy for you to then solve this. You solve the remaining variable, which is that one variable I've just spoken about. At the end, for you to find the other variable, you will substitute the result you got in step 4, into one of the original equations and then solve. But I know all of this is just language, right? Let's look at a typical example of what we need to do. So you can already see 3x, 4x. I can't really cancel it, right? If I subtract, I will be left with 1x. Either a negative or a positive, it doesn't really matter. If I add, I will get a 7. So I'm not going to consider cancelling x. Let's look at y. Minus 2y plus 2y. If I subtract them, it will give me minus 4. So I cannot subtract. But if I add them, it will give me 0. So it means I must then first start by cancelling the y, solving the x, and then going to solve the y after. So I will firstly call this equation 1, and I will call this equation number 2. Most of the time, that's really easy for you to do because you can just say equation 1 plus equation 2 because it's a language, guys. You need to communicate with me and tell me what you are doing because I don't just want to see things, right? So 3x plus 4x will give me 7x, minus 2y plus 2y will be 0, equals to the 8 plus the 6 will then be 14. Divide both sides by x, I get, by 7 I get x is equals to 2. Now remember my last step, right? Which is step 5. You substitute the answer, which is what I just got now. I got my x as equals to 2. You substitute that into one of the original equations. I'm going to do it with both of them so that you can see what I mean when I say into either one to then solve the other variable. So if I substitute it, 3x minus 2y equal to 8. So 3x minus 2y equals to 8. If I substitute my x as equals to 2, I will get 3 into 2 minus 2y equal to 8. This is 6 here, so it will be 6 minus 2y equal 8 minus 2y equal to negative 2. Positive 2, because it's going to be 8 minus 6. Then my y will be equals to negative 1, right? So it means my ordered pair for now will then be the 2 and the minus 1 there. Remember what we did when we were drawing the two graphs. That's where these points were intersecting. But let's look at if I use the other equation now, which is 4x plus 2y equal to 6. 4x plus 2y equals 6. It will be 4 multiplied by the 2 plus the 2y equal to 6. 4 multiplied by 2 is 8, so this will be 2y is equals to 6 minus 8, which is 2y equals to negative 2. Then my y will be equals to negative 1. So even with this, it will be 2 and minus 1 as an ordered pair. So this is how we can then use this. But now let's look at another question that involves this, right? Where you cannot just cancel from the get-go. X and 2x, you can't cancel them, right? Because they are not like terms. Not like terms, they don't have the same value. 3y and y, you also cannot cancel them. Why? Because they don't have the same value. If I add the x and the 2x, I will get 3x. If I subtract them, I will either get a plus or a minus x, so it means I cannot do that. If I go to the y and I add them, it will give me 2y. If I subtract them, it will give me 4y, right? Still, I still have the two variables, so I must do what? I must go back to my steps. Let me show you. Remember the second step. I said multiply one or both equations by a constant that will allow you to then, cancel out one variable. So what does that mean? I can just say I'm choosing 3. I'm choosing x, to cancel x first and solve for y. To do that, it means this x here must be 2x. that will remain 2x. So it means I must multiply this by 2 in order to make that 2x. But remember, mathematically, what you do on one side, you must do with everything else to maintain the balance. So this will now be 2x plus 6y equal to 24. So I multiplied it with that, and with this. And then this will be 2x minus y equals to 5. Right? And then remember I said just try to label them. Equation 1, equation 2, excuse me. Then I will just say equation 1 minus equation 2. So it will be equation 1 minus equation number 2. So to do that, 2x minus 2x will be 0. 6y minus y will give me 7y equals to 24 minus the 5 there will then give me 19. So let me quickly verify that I've done the right thing here. It will be 6y minus that, which is definitely 7y. Then the 24 minus that will give me the 19 there. So it means now I am at 7y equals to 19. Then y will be equals to 19 over 7, right? Why am I getting a fraction? Oh, yes, so you do get a fraction at times, because then I was just quickly looking at whether there's something we did not do right. So that is 2, that is 6. 12 by 2 is definitely 24. You subtract, you definitely get this, all right? So I can choose either of the two original equations, right? So I will take the first one, which is x plus, I think it was 3y equals to 12. You substitute that y there, so it's x plus 3 into the 19 over 7 equals to 12, and then you solve, right? So x will be equals to, all right, so if we press this in our calculator, it will therefore be 3 open bracket into the 19 divided by 7, which will give me that. So it will be 12 minus that answer, which will give me 27 over 7. So this will be 27 over 7. Now, so my ordered pair will be the 19 over 7, but that's the y, so the x will be 27 over 7. Now, the last example that we're looking at, this is easy as well. Firstly, you just label this as 1, label that as 2. Then you will just say 1 plus the 2. If you add them, you will have 3x equals to 12. Then my x is equals to 4. And then to find the y, it will be 4 minus y equals to 3, which will therefore make negative y is equals to minus 1, then my y will be equals to positive 1. And therefore, the ordered pair will then be the 4 and 1 as the answer. Remember, always label them, make it a point that one variable, if you add or subtract, can be cancelled, and then solve the other one, and always write it as an ordered pair at the end. All right, guys, that's it from me. I hope you've been enjoying and you are still having so much fun with me. But for now, I want us to stretch a bit, just drink some water so that you can be a bit refreshed. And when I come back, we'll then look at some more work that we need to do together. Please stay tuned. Hi guys, welcome back from the ad break. So we are still busy with trying to solve simultaneous equations, right? So far we've looked at the first method of solving simultaneous equations. Now we're going to look at the second method, which is the substitution method. So let's just have a look at what are the steps that we need to follow, and then I will take you through a step-by-step solving process of a specific question so that you can see what I'm talking about. So let's have a look at it. Now, so substitution method will be solving simultaneous linear equations. That is, the very first step will be you get a variable by itself in one of the equations, right? What does that mean? It means you must make one variable to be the subject of the formula, subject of the equation, right? So in terms of x equals to, or let it be y equals to, and it doesn't matter what is on the other side, but the goal is to either make x to be on its own or to make y to be on its own on one side. But obviously, if I have x on its own here, I can't have on this side 2x plus y minus 5. Then this will not make sense, because minus 8, I mean, because it means x is no longer on its own because I have x on both sides. Similarly with this, with y, I can't say it's y is equals to y, 2y rather, minus 3x plus 5, right? I can't say that. I must make sure that everything that has y is on one side. Everything that has x is on one side if I'm choosing x. And then the second step will be you take the expression you got, right, for the variable in step 1, and then you substitute it into the other equation. So if I have given you two equations and you've labeled this as equation 1, you've labeled this as equation 2, right? Let me just say ax plus by equals to c, right? And x minus by equals to d, right? So I take equation 1 and then maybe I make x to be the subject of the formula. That equation that I formed after making x the subject of the formula, I will then take it and substitute it into the equation that I did not use. Because if I substitute it back to what I used to make x the subject of the formula, it will give me 0 is equals to 0, which will then be no use for me to solve anything, right? So please do bear that in mind. But I'm going to do a specific question where you will see what I'm talking about here. Step 3, you solve the equations in step 2 for the remaining variable, meaning if only x is remaining after substituting, then you solve for x. If only y is remaining, you solve for y. Then lastly, you use the result that you got. So if you solved for x, you're going to substitute the x into one of the equations, which is the equation that you did in step 1, right? If you solved for y, then you will use y for the equation that you used on step 1. But let's actually see what exactly do I mean here. Now, let me just show you where this comes from, right? I know x is already the subject of the formula, but this is the same as maybe me having x minus y equals to 2, you see? And I chose to make x the subject of the formula. Or it is the same as x minus 2 equal to y. Then you can take the 2 that side, or you can take the minus y that side, which then becomes this equation here. And then already step 1 is already done, right? So I don't really need to then do that. So for step 1, I will just say x equals to y plus 2. This is equation number 1. And then I will say my 3y minus 2x equals to 15. And this will be step number 2. Now, with elimination method, we spoke about rearranging the terms. But here you don't need to rearrange them. Why were you rearranging them? It's because you wanted the x's to align with one another, the y's to align with one another, the constants to align with one another. But here I'm just going to be substituting in a value. So I don't need to have them aligning with one another or anything of that sort. So you don't need to worry yourself about rearranging them or anything of that sort. You just need to then substitute as soon as one variable is left to be on its own on one side. So to do the substitution, which is my step number 2, right? Let me quickly verify that. Take the expression you got and substitute it, right? So to do that, it means I will have 3y minus 2. What does equation 1 say? Equation 1 says you need to sub, or step 2 rather, sub equation 1 into equation 2. What does this mean? It means that wherever you see x, you are going to replace it by y plus 2. Wherever you see x, you are going to replace it by y plus 2. So this will therefore be y plus 2, and this is equals to 15. Already you can see I only have y as the variable there, right? Then my third step says I must solve. So remember, this was 3y minus 2 into y plus 2, and this was equals to 15. Remove the brackets, I get 3y minus 2y minus 4 equal to 15, and then it will be y is equals to 19. Then the last step, I got y equals to 19. I must substitute it into this equation, so that will be x is equals to 19 plus the 2, and then my x will be equals to 21. So let's quickly run through what we've done so far. Step 1, you must make one variable the subject of the formula. Already it's there, it's the x, so I don't need to do that. Step 2, you substitute. Wherever you see x, you replace it by what it is equal to. Step 3, you solve for the variable. That's where I got my y is equals to 19, because the 15 plus the 4 will be 19. And then lastly, I substitute that into the first equation, which will then give me x as equals to 21. Guys, I hope that really clarifies how to do substitution. But for now, I want us to take a quick ad break just to digest what we've spoken about, and then I will bring more questions for us to do in order to see what we need to do. So stay tuned, I'll be back just now. Hi guys, welcome back from the ad break. So as I promised you, we are actually going to look at a few questions that employ all these things that we've been trying to look at, right? Remember, we looked at solving simultaneous equations using the graphs, but that was just me trying to show you where the point of intersection is, which is that unique point that satisfies the two equations that I would have given you. And we also looked at the elimination method and the substitution method. And those are the two methods that you're going to be using from now going forward with your mathematics career. So make sure that you do learn these properly. But for now, I'm going to take you through the examples. I'm not going to do them step by step, as I said, right? So I'm not going to write step 1, step 2. No, I'm just going to do it as one collective thing, but I will be showing you where what comes from. So let's just have a look at it together then. Now, the very first question, all the time they will say to you, solve for x and y simultaneously. That's the question. And remember, I said the very first thing you need to make sure you look at is whether from the two equations that I've given you, can I make sure that one variable is cancelled, either by subtracting or by adding, and then I solve the other variable. So here, the 3x and the 4x, if I add them, I will get a 7, so I cannot. If I subtract them, I'm going to get a negative x or a positive x, so I can't do that either. We go to the y, minus 2y and 2y. If I add them, definitely it's going to give me 0. If I subtract, it's going to give me a negative 4y, so I must then choose addition. So I will quickly label this equation 1. I label that equation number 2. So my main step here will be to say equation 1 plus equation 2. Remember, I said you need to communicate with me as you are doing your work. The 3x plus the 4x, will then be 7x, minus 2y plus 2y will give me 0, and then 8 plus 6 will then give me 14. Divide both sides by x, you get, by 7 I mean, you get x is equals to 2. Then remember, the last thing that you always need to do is to take the first variable value that you solved and substitute it in either of the two equations that you are given in order to find the next variable. So I will just take the first equation. That will be 3 into 2 minus 2y equal to 8. 3 multiplied by 2 will be 6, so this will be minus 2y equals to the 8 minus the 6. And then lastly, I will get negative 2y equals to 2, and then my y will be equals to negative 1 if I divide both sides by negative 2. So this is really straightforward because already there is a variable that you can just cancel out without you having to multiply by a constant. Now, if that is not the case, like in this particular example, you can either use elimination method or substitution method. But make sure that when you choose the substitution method, you make sure that the variable that you choose to make the subject of the formula does not give you a fraction on the right-hand side. Because I promise you, as much as fractions are a bit difficult to deal with, it will really work on your nerves and you will then panic because fractions are not really an easy thing to work with, right? So make sure that you always make it a point that if you use substitution method, there is no fraction that you are having there. If there is, then multiply by the LCD to get rid of the fraction and then employ the elimination method. I will promise you now, elimination method works at all times, but before it works, you need to do the following. So I have 3x and 5x. They cannot cancel. I have 2y and 3y. They cannot cancel. So it means I must then make a decision whether I want to start with cancelling the x or cancelling the y by multiplying by a constant that will make whatever variable I'm choosing to have the same value. So I will just choose, let's choose y, right? Because I know that people always start with x. And when you are multiplying, you will multiply by one constant that will make this 2y to be the same as the 3y, but there is no constant that I can multiply 2 by to give me 3, meaning I must also go to the 3 and also multiply it by something. So I will multiply here by 3, I will multiply there by 2. Mathematically, you know what you do on the left, you must do on the right, and with any other term that is there. So if I multiply the 3 by the 3x, it will give me 9x. The 3 by the 2y, it will give me plus 6y. The 3 by the 6, it will be equals to 18. And then we go to the second equation. The 2 by the 5x will give me 10x. The 2 by the 3y will therefore give me 6y. And then the 2 by the 11 will give me 22. Then now this is my equation 1, this is my equation 2. Now guys, you can really see that if I wanted to reverse this and go back to what the question was, I can just take equation 1, divide everything by 3, it will go back to what I originally had. I will take equation 2 divided by 2, it will take me back to what I originally had. So I did not change my equation, I just wrote it in equivalent forms. Remember when you did equivalent fractions at some point in your maths career. So you can then choose which equation you want to use. Most of the time I prefer choosing the equation that has the biggest values and subtracting the one that has the smallest values. So I will say equation 2 minus equation 1. So 10x minus x will give me, minus 9x will just be the x. 6y minus y will be 0 equal to 22 minus 18 will then be 4. Already I know what my x is, right? Now I'm going to choose any equation. And I said when you are choosing the equation, you go to the original equations you were given. Don't use the ones that are equivalent forms of the originals, please. So I will choose 3x plus the 2y equals to, this was equals to 6. And remember we got our x as equals to, because that's what we started with, 4, right? Okay, so we got x as equals to 4. So this will be 3 multiplied by 4 plus 2y equal to 6. 3 by 4 is 12, so this will give me 2y equals to 6 minus 12. Then 2y will be equals to negative 6. Then my y will be equals to negative 3. And then the unique pair that satisfies this will be the 4 and the negative 3 as my answer there. So elimination method works, right? But make sure when you use it, one variable, if you are either adding or subtracting, will go away. Go away in terms of giving us 0. And you'll be left with only one variable that you're going to solve. And then at the end, you will take that, substitute it into one of the two equations. Remember when we were looking at this, I showed you that both of them will always work. Whichever one you choose, they will both work. Now, let's just spice it up a bit, right? Now I have fractions, as I said. If you have a fraction, then you must make sure you multiply by the LCD, right? So the first example that I have here has 3 and 2 as my denominators. So I must make sure that I get rid of the fractions. To do that, I know that my LCD here will be equals to 6. So I must multiply everything by 6. My LCD for the second one there will then be 20. I must multiply everything by 20. So if I multiply everything by 6 here, it will give me 2 into y minus 2 minus 3 into x minus 1. And this will be equals to 6. Remember, you multiply everything by 6, so 1 must be multiplied by 6 as well. And this will then be 2y minus 4 minus 3x plus 3 equal to 6. Remember to make sure that all the variables are on one side and the constants on one side. So that will therefore be 2y minus 3x equal to negative 4 plus 3 is minus 1. Therefore, this will just be 7, right? Then my second equation, if I multiply everything by 20, it will be, I'm just going to multiply it, right? So this will be 4y minus 16, and then negative, and this will be 5x, and then plus 5 multiplied by the 3, there will then be 15 equals to 20. Simplify this quickly, it will then be 4y minus 5x equal to minus 16 plus the 15 there will give me negative 1, so it will be equals to 21, right? So now you can see I have two variables, but both of them, they cannot be cancelled if I use my elimination method, so I must first change them. So I'm just going to quickly write them in the new slide here. So this is 2y minus 3x equals to 7. And the second one we said was 4y minus 5x. 4y minus 5x equal to 20. 21, yes, 21. And then you just need to quickly change this one by multiplying everything by 2. So this becomes 4y minus 6x equals to 14. This remains the same, 4y minus 5x equal to 21. Then this is my equation 1, this is my equation 2. Now I will communicate and say I'm subtracting. Remember I said always take the one with bigger numbers, right? So I'll just say equation 2 minus equation 1. 4y minus 4y is 0, minus 5x minus that. So let me just write it for people like myself who are still trying to understand this. Minus 6x is equal to 21 minus 14, there will just be 7. That one I'm sure you are clear about. So this will then give me negative 5x plus 6x is equals to 7, then my x will be equals to 7, right? And then I solve for y. You can choose either one of the two equations, it doesn't really matter. So I will take the first one, which is 2y minus 3 into 7 equals to 7. So this will be 2y equals to 3 by 7 is 21, plus that will be 28. And then lastly, my y will then be equals to divide both sides by 2. It then gives me 14. So my ordered pair will then be 7 and 14. And that's the one that satisfies these two equations that I had. So we started with a fraction. You get rid of the fractions by multiplying by the LCD, and then continue with changing one of the variables so that it can cancel out. Guys, just to summarize everything that we've looked at so far, make sure that you revise the meaning of the word simultaneous. I know the English version of it just says at the same time, right? But mathematically, you need to look at it as well as to what does it mean. You need to practice solving linear equations by both the elimination and the substitution method, because they're not really going to specify which method you must use in an exam or a test situation, but it's always good to know both of them, because at times you'll try elimination and you see that, hey, it does not work. Then just go to the substitution than to cram one, and then if you cannot do it anymore, it's a problem. Remember, the solution of two linear equations is always the point of intersection of the straight line graphs if you draw those two linear equations. Guys, I hope you've had so much fun, as much as I actually did. And everything that we've done, you've written down some notes and some question marks that you're gonna go back and relook at if you did not understand. But from me to you, the Maths Doctor, remember, mathematics is food for the soul. Until next time.